Guess that about does it. I'll give you a check. $130 billion. That's the staggering one-year total of America's consumer goods business. Are you getting your share? More important, are you getting your share of the profits? Do your production techniques and your production equipment add up to the production economy that means profits? In these days of high taxes, high wages, and high costs, a good look at your production efficiency can be worth good money in black ink. And production efficiency starts with production equipment. Regardless of what you make, is your equipment quick and easy, and therefore economical, to clean and to keep clean? Does your equipment give you maximum capacity in minimum space? Can you quickly and economically modify your production equipment to take full cost-saving advantage of improved techniques? If you use heat, is your heat-up time fast enough and your heat transfer uniform enough for truly profitable operation? Are you burdened with a heavier investment in equipment than necessary? Or is your equipment the kind that minimizes first cost while assuring you of extra long, trouble-free life? Do you run the risk of contamination and loss? Or does your equipment give you complete protection of product, color, taste, odor? Does corrosion or abrasion eat into your profits? Can your equipment shrug off corrosion or abrasion while assuring you the uninterrupted production that adds up to extra profit? Is your equipment made of a material with corrosion-resistant ratings like these against an A to Z list of chemicals like this? Of course, you may be one of the fortunate few. But the chances are you'll find your profit is leaking through production equipment that's not up to top efficiency and economy. And that's where I come in. For I sell the makings of the most efficient, the most economical production equipment in my entire field. I sell clad steel. Steel clad with many of the stainless steels or nickel, Inconel, Monel, or copper, from 5 to 50% of the total plate thickness, pressure bonded at high temperature to the steel backing so the whole plate becomes a homogeneous unit. backing steel can be any type of steel, carbon or low alloy, required for a specific application. And the backing steel can be clad on both sides if required. My point is this: you can make more money if you use clad steel production equipment to solve such problems as product contamination, cleaning difficulties, corrosion, heating and cooling, or related production troubles. And I'm going to show you how and why. So let's get down to cases. Each type of construction has its place in modern industrial processes, of course. But note well that only the clad vessel and the solid high alloy vessel has complete solid construction with interior and exterior walls, one inseparable unit. And therein lies one of the principal advantages of clad construction. Since there's a solid bond between inner and outer walls, there's no loose lining in clad vessels to bulge, buckle, or flex, even in the frequently used cyclical and vacuum processes of modern industry. The ease and economy of fabricating or modifying clad equipment is another distinct advantage. Since the plate is homogeneous, attachments can be welded directly to the cladding with complete structural rigidity and safety, and without impairing the cladding in any way. If this vessel were clad steel, there'd be no need to cut through to the backing plate to make the weld. No danger of corrosive seepage of caustics or acids between lining and outer wall. No patching to be done if the attachment is later removed. Compared with many other conventional materials, a clad vessel's metallic walls are hard, dense, and thinner in cross-section. And since clad steel is worked like any solid plate, vessels of rectangular, cylindrical, or irregular shapes can easily be designed and fabricated for maximum space utilization, as well as any requirement of process desirability. It should be noted that the ASME code permits use of total clad plate thickness in design calculations, not just the thickness of the backing plate alone, as is the case with line vessels. And when it comes to heat-up time, as this experimental setup shows, stainless clad vessels heat up faster than vessels of solid stainless. This applies to all the alloys, except nickel. In that case, heat-up time is the same. Naturally, the alloy working surface of clad steel vessels has every one of the valuable properties of the solid alloy without the heavy cost or extravagant use of high alloys that solid alloy construction would require. As a matter of fact, clad steel equipment has been making money steadily for American industries since that day back in 1930, when this, the first piece of clad steel equipment, rolled out of the car builder's shop. It was built for a chemical company that had to transport caustic soda without iron pickup. High cost made a car of solid alloy out of the question. So engineers of Lucan Steel and International Nickel came up with a nickel-clad steel solution to the problem. Still in regular service after more than 2 decades, this tank car showed the way for clad steel to go on through the years, solving equipment and process problems for industry. Then, as now, Lucan's clad steels are produced in the company's plant at Coatesville, Pennsylvania, where practically a quarter-century's experience has made the manufacture of clad steel a high art. Let's get the plant superintendent to fill in some of the details for us. Have you time to tell us how clad is made, John?
Sure, always have time for that. The first thing we do to make a clad steel plate is get the alloy plate, called an insert, and the carbon steel backing plate absolutely clean. We take the time to do it thoroughly, because scrupulous cleaning is one of what you might call the secrets of making clad steel. Next comes nickel plating, done on most alloy slabs except nickel, of course. This is an important step that helps get the solid bond between cladding and backing plate that makes clad equipment so good. Nickel plating also acts as a buffer to limit possible carbon migration from the backing plate. The next step is to arrange the alloy plates, separated by a specially developed parting compound, and the steel backing plates into an assembly that we call a sandwich. We make clad steel plates 2 at a time, one on top of the other in the assembly, with the alloy plates inside. You can get a better idea of what an assembly is like from this model. Each assembly is built up of the carbon steel backing plate, then the alloy insert, separated with a parting compound from another alloy slab, and finally, another carbon steel backing slab. The thickness of each layer is carefully computed on the basis of finally desired thickness, assuring uniform thickness of the cladding in the finished plate. Now, the whole thing is welded together all the way around the edges to maintain alignment during rolling. After rolling, this alloy and steel pair will be bonded into one clad steel plate, and this alloy and steel pair bonded into another clad plate. The assembly is always built up steel out, so the cladding is protected from the atmosphere in the soaking pit and during rolling. Of course, an assembly must be heated in the soaking pit before rolling. At our big rolling mill, you can see heated assemblies ready for the rolling that reduces them to plate thickness and pressure bonds the cladding and the backing plates. Our mill can roll clad plates up to 178 inches wide and other plates up to 195 inches wide, and it's kept mighty busy. Then the sandwich is flame cut inside the welded perimeter and separated into 2 plates. After that, we heat treat our stainless clad plates to increase their corrosion-resistant qualities. The next step is treating the plate in our giant sodium hydride descaling plant. Descaling and pickling make the surface of Lucan's clad steel smooth, scale-free, and really easy to keep clean in service. Next, the plates are flattened, or leveled, as it's called, by means of rollers for the heavier gauges and by actual stretching of the lighter gauges. Then, after the level plates are sheared to size, they're polished, if required by specifications. As a matter of fact, Lucan's gives you a wider choice of cladding metals and a wider choice of finishes than anybody else in the business. Aside from clad plates, we make the largest variety of clad heads in the industry. Spinning a head to exact dimensions is tricky. Takes a great deal of experience and special equipment. We've got both, of course. So fabricators save time and money and avoid responsibility by having us spin or press their heads. Our heads are always beveled for welding before shipment. We prefer it because we can thoroughly inspect the bond, and our customers prefer it because it saves fabrication time. Well, that's it. Wrapping and shipping the finished clad steel plates about ends the story.
Thanks, John. But the story is just beginning. For it's here in the shops of our customers, the equipment builders, that clad steel plates and heads become clad steel equipment. The clad steel tanks and vessels and piping of all kinds that cut costs and boost profits for manufacturers everywhere. Clad steels provide such a fine metallurgical combination of corrosion and abrasion resistance and workability that smart fabricators like Mike O'Donnell here can do anything they want with it. Right, Mike?
Sure thing. Of course, clad steel has its problems, but so does any material. Working with it is simply a matter of knowing the right way and doing it that way. Take flame cutting, for instance. Clad steel is a tough, durable material. It has to be to do its job. But you get a clean cut easily just by setting up and using the torch right. Shearing is no problem either when you do it correctly, clad side up. Getting the right edge for fitting up and welding is easy enough. Naturally, though, it takes a little longer to machine clad steel than, say, plain carbon steel. Clad is rolled either hot or cold. Of course, you have to keep the rolls clean of chips and burrs so you don't mar or contaminate the smooth alloy finish. Like any good shop, we consider a weld unsatisfactory unless it's just as strong and just as corrosion resistant as the original clad plate. So we do it right, steel side first, using electrodes with the same characteristics as the backing plate. And naturally, taking care to get a good root bead without penetrating into the cladding. When the men are ready for the clad side, they first chip and grind down to sound weld metal. Then, using the right electrodes for the job, there's really nothing to it. Our customers certainly have been keeping us busy making clad steel equipment. You have anything else in mind?
Sure have, Mike. A lot. Actual firing line examples of businesses all over the country that have plugged up their profit leaks with clad steel equipment. This big paper producer, for instance, where every man is constantly on his toes to turn select wood into fine quality paper. Cleanliness is vital to paper quality. So to lick skyrocketing cleaning costs and downtime from lumps, the equipment builder recommended smooth stainless clad for the head box. Now, because it's a breeze to hose down the rounded interior contours and the hard polished walls of the new head box, slime can't even get a foothold. So costs are down and quality, as well as production, is up. Out in Detroit, there's a proof in action story of the sheer rugged strength of clad steel equipment and its ability to resist severe conditions. In the words of one of their engineers,
in a power plant, you gotta have steady, uninterrupted movement of coal from bunker to stoker. Any stoppage in the steady flow of fuel is four-alarm trouble and plenty costly. You may not know it, but moisture acting on coal produces powerful acids. It used to be that corrosion plus abrasion not only cut the life of our carbon steel chutes to 2 or 3 years, but also contributed to rat-holing and arching that drove us half crazy with fuel stoppages. But not anymore. Now our chutes are clad steel because we found clad steel's immunity to corrosion, its low coefficient of friction, and its design versatility make it just right for us. Our clad steel chutes have already lasted twice as long as the older carbon types, and they're still going strong.
whether the problem's handling coal or controlling corrosive floodwaters, you've got to have rugged, super tough equipment. Equipment, for instance, that can stand up to the endless hour after hour, year after year beating of corrosive water laden with acid waste and debris. So in the vital sluice gate system of this big flood control project, rugged, durable, corrosion-resistant clad steel was chosen for gate frames, gate leaves, and conduit liners. Yes, for the assurance of dependable operation in any emergency and long maintenance-free equipment life, you too can look to clad steel. In this soap maker's glycerin distillation system, high fuel consumption and low throughput used to be problems.
Management specified that our new distillation setup had to increase production without resorting to multiple distillation, and at the same time, reduce fuel costs. It was a tall order, but we did it with this soundly designed still, fabricated of clad steel. Reduced heat-up time and a faster distillation rate have boosted our throughput almost 3 times, while saving as much as $7,000 a year on fuel. And in addition, the new equipment resists the corrosive effects of highly salted crudes working at 330 degrees, and it stands up under vacuum operation. All that, plus important savings on original equipment costs.
In processing vinyl plastics, heat transfer is a problem too. Unless temperatures can be accurately controlled, proper reactions just don't occur, and that means costly spoilage. So, when engineers of a big plastic producer were designing these jacketed whey tanks for their Michigan plant, they specified clad steel for the inner shells, for rapid, even conductivity from the compounds in the tank to the coolant. At the same time, of course, the corrosion-resistant clad steel surfaces eliminated any possibility of the metallic pickup that would cause off shades. Fast, accurate weighing of pure, color-true chemicals combined with low maintenance was the profitable result. And so it goes from industry to industry, from installation to installation, from coast to coast, and throughout the world. Here at the Naval Air Turbine Test Station, Trenton, New Jersey, for instance, important jet engine experiments owe much of their success to the strength and corrosion resistance of clad steel. The complexities of its construction are made clear by this completely detailed scale model of the laboratory. In the laboratory itself, vital piping, dehumidifying and refrigeration equipment, and many special valves are all fabricated of enduring clad steel to avoid the need for protective painting or coating of the inner surfaces. During tests that range from 200 degrees to minus 75 degrees, the smooth, hard, clad surfaces of the dehumidifying and refrigeration units, as well as the piping, eliminate the danger to valuable jet engines from flying rust or flakes of paint or sprayed-on metallic coatings. Nickel steel, specially developed for low-temperature service, and one of many available special-purpose backing materials, assures positive resistance to sudden, violent pressure and temperature changes. That's why Navy engineers specified clad steel for the high-priority work of this laboratory. In the making of antibiotics, such as chloromycetin, any kind of product contamination, metallic pickup, bacteria, even in submicroscopic quantities, simply can't be tolerated.
That's why we specified clad steel for this 5,000-gallon fermenter and for other equipment in our new plant. The polished interior surfaces mean maximum sanitation and quick, easy cleaning. Clad steel means absolute product purity in many other applications in our plant. Intermediate fermenters, filter cake receivers, and adjustment tanks. Clad steel equipment's real economy for us because it prevents contamination. Another point, since the exterior of a clad steel vessel is carbon steel, it can be easily and economically painted to match the color harmonics of your plant.
In selecting the material for the two-stage distillation unit of this big refinery, engineers were faced with a double-barreled problem.
The material for both vacuum and atmospheric towers had to be able to resist the corroding effects of heavy sulfur concentrations at high temperatures. And on top of that, the material for the upper part of the atmospheric tower would have to stand up to the corrosive action of condensing chloride and hydrocarbon vapors. One material couldn't do both jobs well. So, after careful study, our engineering contractors recommended two types of clad steel for the atmospheric tower. Monel clad steel for the upper section, stainless clad steel for the lower section. Lukens could, of course, provide both. And for the vacuum tower, they recommended stainless clad steel throughout. Fitting the material to the job has really paid off. In low first cost, in easy economical field direction, in flexible economical operation, and in enabling our equipment builder to use the largest head ever spun, over 20 feet in diameter. By forming the head in one piece instead of in sections, we got a better unit in less time and eliminated the added expense of complicated fit-up and fabrication in the field.
No matter where the industry or what the industry, the story is the same. Clad steel plus good engineering plus good fabrication is a combination that process problems just can't beat. Corrosion, causing short equipment life, was the problem facing this big Northwestern pulp and paper outfit. As a matter of fact, the frequency of digester failures in the pulp and paper industry prompted Lukens to make a thorough study of the problem.
And that's why we decided to have these vertical sulfate digesters fabricated of clad steel. Sure glad we did. The highly corrosive cook, working at 300 degrees Fahrenheit, doesn't seem to phase the clad at all. And neither does the shock of a cold charge hitting the digesters while they're still hot. We've had none of the failures we had with our old equipment. Increased digester life alone has saved us thousands of dollars in replacement costs. Also, downtime and maintenance expense have been greatly reduced.
Clad steel digesters pay off in other ways, too. For example, another mill reports that lighter gauge clad steel digester shells have boosted capacity 27% in the same plant space compared with their older, thick-walled, ceramic-lined equipment. One more proof-in-use reason why we say that equipment, properly engineered, fabricated by progressive equipment builders, of rugged, economical, versatile, clad steel, is one sure way to profit.